Okay, it looks like we're going live. Hopefully everybody can see me and hear me. I'm going to move this forward just a little bit so you guys can see that we have a live briefing here. It is the 28th, and hopefully everybody can see me and hear me. Yes? See me and hear me? My 5x9, hopefully? It looks like we're all moving just fine. Everything looks good. Whoops, I got to make sure that doesn't start. Okay, good. No echo. Sound check was good. Thank you, Mike. I appreciate that. I'm glad Mike Richardson is on, and you may see Jerry Ryan here shortly. Both of them are moderators of the chat, so they will keep everybody honest and on topic. Okay, so we are all here to learn and understand what's going on. And yes, good. Everybody is seeing me and hearing me. Good to see you. Good waves, Mike. I see Vince Nobooks in here. Oh, good. I have a fly in here too. Wonderful. So we have a little friend. If you see me batting the air, that's going to be because I have my little flying friend I've got with us today. Everybody had an issue with a 400 megahertz band. I don't know. That's a really good question for this group of people. So that's good. 5x5. Excellent. Okay. So yes, so for those of you who know the coded shirt, I am wearing a red shirt, and that's not so much because you have anything to worry about. It's more to do, the red shirt more has to do with those of us who are in the forecasting realm, and this doesn't matter if you're a formal forecaster or if you're an informal forecaster, whether you do it for just enjoyment out of being a space weather enthusiast, or if you do it as a profession. We need to understand that this solar cycle is not like solar cycle 24. We are consistently under-predicting these solar storms, under-predicting their speed, and under-predicting their magnetic field strength. And I've seen it time and time again. I myself I am just as guilty. I think we all are guilty. And the reason is because this is not the same sun that we had 10 years ago. This sun is getting stronger. And so we have to kind of harken back to some of the older solar cycles when they had bigger events, and the things that we see in coronagraphs now, we need to look at them with an eye for strength as opposed to weakness. So this solar storm was expected, and it is a glancing blow, and I'm looking at, if you're wondering what I'm looking at real-time data right now. I'm watching it unfold, and anybody who's gone to the Space Weather Prediction Center page, for a few moments it has been down. I'm not sure if it's gotten back up. I think it's gotten a lot of traffic today, so it's a real good test of their new servers. Anyway, we're going to go through that. We're going to go through the BLUF. I'm going to give you the bottom line up front to show you what's going on with our sun. Those of you on Patreon, you have seen this particular eruption, so you know, because I gave a few days ago, I gave you guys a bit of an update in a snapshot. So we will go over this and talk a little bit more about it, and then we'll do a deep dive, okay? So hello everyone, and I'm glad everything looks good. Could this be due to magnetic field weakening? That's good waves? No, this has nothing to do with the Earth. This has everything to do with the sun. This is just a stronger storm, and in fact, it's not even sure it's going to stay all that exciting, okay, because it's a glancing blow just as we expected, and we'll talk about the details, probably more in the deep dive. So let me get started. Let me take this chat off real fast so that we can, let's see, I think that's it right there. Okay, good. All right. So let's dive into this, shall we? So for those of you who are in my Patreon family, you've seen this. There were so many filaments on the disk over the past week that have erupted. It's been crazy. I couldn't even label them all, so I ended up having to make little tags to label them all because they're all shooting off all at once. The filament that you're going to be interested in is this puppy right here. Okay, this big, long, snake-like thing. We've been watching this thing since it was a baby, so to speak, rotating into Earth view over the past week. And we've been waiting to see whether or not it would erupt, and it finally does. But let me roll through this. There are so many different filaments on the Earth-facing disk. You can see there was one whoosh right here. I call that filament launch 1. Of course, you're getting big eruptions off of the side. Those explosive ones are not necessarily filament eruptions, and I didn't label them. But you'll see, can you see all this? So here's the one we want to keep our eye on. You've got another one here. You've got another one up here. You've got one here. You've got one over here. Are you getting to get the picture? You've got one down here, you got one over here. I mean, there are so many little snake-like filaments, and these are basically like big rivers on the sun. So you can see one lifting off right here. This will be filament launch number 2. You'll see that, and this was back on the 23rd, okay? So we keep going. There was another explosion that way that was not necessarily a filament eruption, but here's a light lift. You're going to start seeing some slight brightening from the filament channel. These are like rivers of what we call plasma, and they erupt, and they'll leave these very kind of bright ribbons. They're not super bright. They're not typically as eruptive as big solar flares from active regions, but they still can give us a bit of an X-ray signature. So there's another filament. Then we had this one go right here. That's filament 4, and then we had the same time we had filament 5 off the pole. See why I had to label them all? There are so many. And as we continue to rotate into Earth view, look at all the active regions, right? So right around here, this is what I'm lovingly calling the Gannon region, okay? This over here is the return of old region 3644 or 3697 or now maybe 3723 or 28, or it's kind of broken up into a bunch of little pieces. We're calling it the Gannon region after Dr. Jen Gannon, who passed right about when this region was emerging. And she was a very important figure in operational space weather. She's part of the reason why we have magnetometers on the ground in the United States, in the ways that we have them. So she was a very big player. She was also a member of the SWAG community, the Space Weather Action Group, and they have been helping SWPC at NOAA figure out how to move into the future, become 21st century ready. So her loss, the loss that we had from Jen, is pretty substantial in our community. The last big G5 storm was called the Gannon storm. I'm calling this the Gannon region, okay? It's a lot easier besides having to call it, you know, all these different numbers. But this is the region that is now, we're seeing it for the 3rd time. This is where we expected lots of big activity. This is why I'm calling this an unexpected G4, because almost everybody who has not been paying attention to the sun will assume the G4 storm came from this, okay? So you'll probably see it in the media. Not true, not true, not true. For those who are very quick to correct the media, please do so. Make sure they don't link this recent G4 storm with this region. It's not where it came from. It's coming from this filament, okay? Now, if you've been watching this filament, it's continued to rotate in all the way to the west limb, okay? Look how long this thing is and look how big it is, right? So when this thing launches, it's a big, dense thing, but it also launches very slowly. Okay, so here we are. Let's get back to this. We're filament 4, filament 5, as you can see, the starting of filament 6. Okay, these things continue to erupt, and then watch this puppy right here. This will be filament 7. Now watch it right here. And I changed the color so that you can actually see. So when it erupted, and actually if I go backwards, you should be able to see. I'm having a hard time seeing it on my screen. Do you see it? Oh. Maybe it comes later. Maybe it'll come after the coronagraph. I'll see if I can find it. But you'll actually look for like a loop structure, a very light loop structure that lifts off. You can actually see it in the low corona and in the middle corona as it moves off, because this is SUVI, so you get to see the middle corona data. So let's watch it again. You can see it kind of erupt. It looks like a lot of it is going kind of falling back into the sun, like a lot of these filaments did. Falling back into the sun this way and just kind of moving out of the way. But there was a piece that erupted, and you'll see it in coronagraphs here, extremely dense. See that structure? Very beautiful, extremely dense in coronagraphs, but looking like it's moving quite slowly. Let me back that up just a smidge. Okay, so this is why we think it's a glancing blow. We've got a partial halo, but it's not hugely covering the mid central meridian, just barely. So both NASA and NOAA, where I'll show you their prediction models, really have this thing clipping or even missing Earth. Okay, but we knew this thing was coming, but it looks like it's moving very like a graceful giant, very slowly. And with our cycle 24 training from last cycle, big solar storms like this, okay, maybe 10 nanotesla, maybe 15, you know. And so we're not expecting a 20 plus nanotesla big boy, right? We haven't seen those almost the entire cycle Last cycle, we didn't get 20 nanotesla storms. We maybe got it once or twice, and they were very explosive, big things. Now, again, this is extremely dense, so you might think we'd take a hint from that, but this is not magnetic field that we're seeing. What we're seeing here is density. Okay, so because of that, you can't equate the two. You can't say just because you see a big dense structure, you can also have a big solar storm. But in this case, that's what happened, and it's moving much more quickly. But the story's also not done. Because, oh wait, that's right. Let's see if I can go back. Can we see that? There it is. Oh, my mask covered it. Dang it, that's too bad. So if I go backwards just a little bit and then forward a little bit, do you see the tip part of that? I'm so sorry. It looks like I didn't pay close enough attention. My mask cut it off. But it was, if you go look at the data, let me back this up a little bit. See if I can make it go back. Can you see it at all? Ah, no, my mask. The mask is expanding and then it breaks, sadly, so you don't get to see all the corona. I'm so sorry. But if you go back to SUVI data, you can see this structure lifting off. And I'll keep going here. And it lifts off in this big, beautiful loop structure, and you just saw the very edge of it lift off here. Anyway, we've got one more solar storm that launches. You'll see here right between these two, right there. See this small dimming region? This is not necessarily a filament eruption. This is a kind of a ratty, don't know what it is. It is a solar storm. We have a really ratty halo in here. So this is the next storm that's coming for us. Okay. The problem is, once again, this structure is, because it's narrow and it's moving straight out at us, these are hard to model because it's hard to get the speed right. But it looks like it's coming, it's definitely coming essentially straight toward Earth. And depending upon which agency, they have a different prediction. And we'll talk more about the predictions here shortly. Okay, so those are the main structures. We are still watching this filament. This filament here is now in the same position this one was recently. So this one now may be the next one to go. We've already seen it kind of activate a little bit, so I wouldn't be surprised if this thing goes here in the next few days. The Gannon region, though, as you can see, is now kind of spread out with a bunch of different regions. All these guys are quiet. But we'll talk a little bit more about what we see on the far side and what's coming around the bend, and which one of these regions might actually have some more activity coming. We'll talk about that in a little bit. Okay, so that's basically it. What I'm going to jump to now is I'll show you I believe I'm going to jump to the, and that was not a big eruption, so don't worry about it. I'm going to jump to the solar storm. There we go. So now this is going to be NOAA's solar storm prediction model. Of course, it's Enlil, and you're looking down at the sun from the North Pole with Earth being off to the right. There's my little flyby friend there. And the top panel's density, the bottom panel's velocity. So let me put this thing in motion, and you're going to see two solar storms being launched. The first one is that solar storm. That was the big filament, the beautiful filament eruption. And you're going to see this thing really looks like it's being shot off, way off to the west of Earth. Okay. Now you see the second solar storm being launched. This is that tiny little puff that happens center disk. That one is being shot toward Earth, but man, it's just really wispy, right? So this is what NOAA was kind of expecting, right? We've got an impact here from kind of a side swipe from that filament eruption. That's hitting basically down, mainly south of Earth and mainly west of Earth, okay? So NOAA was expecting a small impact, early on the 29th. Yeah, it came faster because we weren't expecting, here they've got a speed of, about 400 kilometers a second, which is kind of what it looked like. It looked like it was just lifting off gently, and it's going to move along the ambient solar wind, which is a speed of about 400 kilometers a second right now. And sadly, I'm looking right now at real-time data, and we're sitting at 500 kilometers a second. So this was faster than we expected, and kind of surprising, but not so surprising if we think back to like solar cycle 22, but surprising when we have our mindset of solar cycle 24. Okay, so that's the first one, but that's what's hitting now, and it does have the signature of a glancing blow, so that means Aurora photographers expect sporadic aurora. Are we going to jump back up to a G4? Probably not, okay? At high latitudes, we may get a G3, maybe. It really depends upon what it's doing. Right now, right now we're getting into a lull because we're in very turbulent solar wind at the moment. And so right now the strength of this thing has really dropped off. We're sitting around 9 or 10 nanotesla completely. Whereas when it hit us, it was over 20. So it hit hard and was really jumbled up, but it looks like things are going to be dying off. So the chances of us sustaining at a G4, no. And this is why I say the red shirt really isn't for anybody who's interested in getting Aurora and stuff like that. It's more for us forecasters to, make sure that we understand that we're under forecasting these, we're under predicting these, and we're doing it consistently, and we need to be better. So anyway, so that's that first one, and then as I continue on, you can see this second one. As a matter of fact, NOAA doesn't even have this thing hitting until like wispily on like the 1st of July. I don't believe that. I think it's going to hit us sooner than that. And part of the reason for that is because we actually have been being hit by solar storms over the last few days, but they've just been so mild that I haven't bothered, alerting anybody to them. And this is probably from some of these filament eruptions. You just saw we had like 8 or 9 of them. And so, we're getting junk. It's just not been all that noticeable in coronagraphs, and so therefore very hard to model. Okay, so expect SWPC's forecast to be pretty flat going out into the 1st of July, but we'll talk about NASA's models here in a second, and the forecast is a bit better. So let me move forward to that. So now we're looking at NASA's prediction model. Of course, again, it's still Enlil, but now you're looking down at the sun from the North Pole with Earth being off to the right, and this is only the density panel. Okay, so let me see if I can set this in motion. There we go. And as it begins, you'll see this solar storm. So we're going to show you 2 solar storm versions, two solar storm models. This is the first one. This has that big filament eruption off to the east, or excuse me, off to the west. And as you can see, as it hits, well, it's barely grazing Earth. So NOAA actually had it hitting Earth better than even NASA did. NASA thought it was going to almost miss Earth entirely. I mean, yeah, just a tiny little finger here. So everybody expected that it was going to miss Earth. And sure enough, it looks like it's almost missing Earth. We just got a bigger impact early on than we might have expected. Okay, but then as we switch to, and by the way, this was, again, this is late on the 28th, so it's earlier than expected, or earlier than the NOAA's model and model's prediction, because NOAA expected it to be early on the 29th. So late on the 28th, but still this thing came even earlier than that. So if I can get this to move to the next one, there we go. You see, here's the center. This is now that small puff that came out. Right, so this, as we watch it come out, NASA has it hitting Earth much, much sooner, and I agree with NASA's impact. This is going to be on the 30th. Right around, early day. So we're going to be kind of moving into this. We're going to get a bit of a bumpy ride through the rest of today. It's going to act there's a very good chance it's going to act more like some fast solar wind hitting us. So like a pocket of fast solar wind. So high latitudes are going to get a lot of potential for Aurora, but it's going to be very turbulent. It's hard to say whether or not there's going to be a lot of southward magnetic field here, because the field is just flipping back and forth. So expect brightening and then backing off and then brightening and then backing off. Stuff like that. Is probably going to be more consistent with what we're going to see until the 30th, or sometime on the 30th when we'll get hit by this. Is this going to be strong? No, I think it's going to be weak, but what I just said is my mind is conditioned for solar cycle 24, right? So possibly could it be stronger than expected? Yeah, it could be, So again, this is more of an issue with us forecasters needing to recognize that this solar cycle is not the solar cycle that we're used to. It's not the same maximum as we had back in 2015. Now, and I don't always do this. I'm going to talk about the far side of the sun really quickly so we know what's coming. And I don't typically use solar orbiter data in this fashion, but I am today mainly because we've got the Gannon region I wanted to show you and what's happened to it, and also the fact that solar orbiter is in a really great place to be able to do this. So we're looking at the actual data. This is not a model, so that's one of the nice things. And so we're looking in red, we're looking at SDO data. This is on the front side of the sun. The blue is the solar orbiter EUI data, and you can see the east limb where, when things rotate into Earth view compared to the west limb. So you're going to see everything in red is the front side, everything in blue is the far side. And you can see back from a few days ago, this is back on the 18th, you can see the Gannon region back here as it continued to wreak havoc and give us a bit of activity on the far side. But as it rotated into Earth view, as you'll see, and I'm going to back this up a bit because I want to show you what's going on the other side too. But you can see we ended up having to change lots of things. We had region 3723 and then region 3728, and it's kind of broken up a bit. So it's a lot softer, a lot gentler than it was. And I don't even know if the Gannon region is going to be, if anyone had to point to a singular region as which one is the Gannon region. I think it's all of these. It's just kind of broken up. So are we going to expect to see much more from this? Not really. The trick is, however, if I flip to this side, and I'm going to back this up so we can see it here. The dates, as you can see, are down here, and I've got this up to about up to about yesterday. And so what I'm backing up for you to see is for you to look and see the regions that are coming into view. Boy, I had to back this up all the way. Yeah, I guess I did. Okay. Now, don't worry about the flickering of the where it's getting brighter and darker and brighter and darker. These are fresh data. Okay, they haven't been processed. They're not science grade data. So don't anyone go do science with these because they're not. They have to be better cleaned and all that kind of stuff. But I'm very appreciative that they put this up so that we can at least get some space weather information from them. So watch this. So this is on the sun's far side. Watch these new regions, okay, including here. And this is the tail end of the Gannon region because you can kind of see it over here. But we got a new region popping up here that's still on the sun's far side. We got another new region that'll be popping up here momentarily. I probably should have made this a little bit faster. You can see here's a new region. Okay, we've got some and another one in here. So we've got 3 or 4 new regions that have been emerging on the sun's far side. And typically when they emerge on the sun's far side, and you can see there's the tail end of the Gannon region, when they emerge on the sun's far side right before they rotate into Earth view, that means, we could, that means we could definitely see some activity here. These are not quite into Earth view yet, so just get ready. Things may actually start getting exciting again in and around the Gannon region, but probably not the Gannon region itself. This region, I think, even though we're seeing it finally for a 3rd time, I think this is the end of it. So we're not going to be worried about big G4 or G5 level storms or big X-class flares from this region anymore. Okay, so that's one of the nice things. Now, as we flip to our moon, since I've got it here, as you can tell, I was getting ready to do a formal forecast, but I'm just using this for the live stuff. As we switch to our moon, we're passing through the 3rd quarter phase on our way to a new moon, and the new moon will be, on the 4th to the 5th. But by the 4th, we're going to have about 2%. I think the moon's going to be about 2% illuminated. So now's a good time. We're getting closer to having a nice dark sky. So you guys, if you want to check for aurora, even weak aurora over the next couple days, this will be a really good time to do it. Okay, so now let's switch to our solar storm conditions and aurora possibilities over the coming week. Now, this is just for today, okay, for the rest of today. At high latitudes, could we possibly see a G3? Yes, possibly, okay, because we've already seen a severe storm, right? We've already got to a G4, but that was mainly the first impact. So I'm giving us about a 60% chance of a severe storm. This is mine. This isn't NOAA. NOAA, they're going to put out some new stuff for starting for tomorrow. Tomorrow, I'm saying that we could be still seeing major storm levels at high latitudes. And the reason for that is because we're sitting at 500 kilometers a second right now for solar wind speed. So we could still, if we get even some small bump ups in magnetic field strength with all this turbulent stuff, and I'd say turbulence in quotes, we could still see major storm levels at high latitudes. Hello. But then as we go to the 30th, expect that the storming, because we're going to have that other storm hit, right? And that should hit us on the 30th if NASA's got their model correct. And I'm pretty happy with their model because, these guys are good. So I'm expecting we could easily see a G1 at high latitudes. Maybe about a 20% chance of a major storm, but probably not going to see it. And then things should settle down after that. Not expecting much more right now because we don't see any other solar storms. There is that one filament eruption, the filament that looks like it's going to erupt in the next day. And if that's the case, then we might start seeing some storming after July 2nd. But right at the moment, looks like things are going to be settling down as we move into the 1st of July. Now, as we go to mid-latitudes, well, again, we got the major storm. This is what I'm expecting for the rest of today. We could see major storm levels. It's going to take a little while for the KP index to drop down. So you're going to probably see still a G6. Don't worry about it. Things are dying off quite quickly. I am giving us about a 50% chance of a severe storm just because in case we see more or that speed continues to go up, it's really hard to say whether or not we're going to pop back inside that structure if it's been distorted or folded. And again, I'm looking at the magnetic field strength, and right now it looks like it's pretty much dying down. We may have seen the bulk of it already and it's all gone. So this may continue to just die down. And then when this storm, the other storm hits, I'm not expecting much. I'm still expecting about active conditions, but I'm giving us about a 10% chance of a major storm. So it's, you can see it's a bit of a spread when that second storm hits, because I just don't know how strong it's going to be. Right? I've still got the mindset of solar cycle 24. But then after that, things should settle down pretty quickly at mid-latitudes, because we're not expecting any super fast solar wind or anything like that. Okay, so now let me switch to our solar flare and Dayside radio blackout outlook over the coming week. Right now, we're sitting at about a 50 to 55% chance of M-class flares. That's at the R1 to R2 level radio blackout, and that's because we have such a large number of active regions, and a few of them are big M-flare players. I'm expecting that will either continue or rise over the next, over the course of this week, because we have those new regions that have just emerged on the sun's far side. Those are going to be rotating into Earth view, and oftentimes when they just emerge, they have a tendency to be a bit more active. So we could be seeing more big solar flares. Right now, our solar flux is sitting around 180 to 185. I think the number right now is 182. I'm causing that to climb. I'm saying it's going to climb just a little bit again, because we have those new regions that are emerging on the sun's far side, and as they rotate into view over the next couple days, that's going to pump us up just a little bit for a little while, but then we're going to have some other regions beginning to disappear off the west limb. So it's probably expecting us to stay just below 200 for solar flux over this course of this week. And we're going to expect maybe about a 5% chance of R3 level radio blackouts. I'm going to say that right now. That may go up as these new regions rotate into view. It's kind of hard to say, but hopefully things will stay about like this. I'm sure amateur radio operators would enjoy being able to get a break since we had some noise during field day, and that was not super fun. Now, switching to our radiation storm or polar aviation outlook over the coming week. We are in the D1 normal range right now, and that's at flight level 360. It's also the S0 quiet range, and everything looks to be in the green. We're going to stay that way easily over the course of this week. We don't really see any big chances for big radiation storms. So NOAA's giving us about a 5% chance for radiation storms right now, and I'm going to keep it probably at 5% even through the 5-day, because it just doesn't look like there's anything there that is going to give us any real problem. So this is the basic BLUF with all the good junk in it. And so I will pause right now and answer some questions. I'll go back to some of this if you need me to, and I'll also, if you'd like for the deep dive, I will pull up some other data and we can look at the Space Weather Prediction Center site, if their site is up. Let me check to see if, because it did not do well a few minutes ago. And I don't know if it crashed or not. I have some real-time solar wind data, but I lost because I tried to do an update. I lost their site. Yeah, it looks like it's not responding. Anyone else want to check that? If you go to swpc.noaa, NOAA.gov, G-O-V, anybody else want to check? Is it just me that I'm not able to get their website for some reason? Because I am not. So let me know in the chat. Did SOHO data go offline for a period, contributing to this sneaking up on us? Well, we've had some spotty SOHO data recently, but I don't think that was the cause. We actually had, this was Mike, you're asking this question. There's been enough coverage that we would have seen it. We also have stereo. So remember, when SOHO isn't always there for us because of keyhole maneuvers. Remember, poor SOHO is it's older than most people in this chat likely, and it's held together by basically the wishes essentially of the scientific community and the determination and grit of the SOHO team at this point, because that spacecraft should never have lasted as long as it has. So it has to go offline from time to time to be able to do keyhole maneuvers and do CCD bakeouts and the like, to be able to get it positioning correctly and keep the instruments functioning well. And it's just a miracle that this satellite continues, or this spacecraft continues to give us great data and be a workhorse for us. But I mean, I know even some NASA M2M folks who are scrubbing back through the chronograph data because they're so dedicated. Thank you, Tony. scrubbing back through the coronagraph data, looking for any ghosts or any indication that we might have missed some Earth-directed storm. So these guys are very dedicated, and I guarantee you if there's something out there, they'll find it. But right now it really looks like this is a storm that is coming, that we saw coming. It's just stronger. Okay. It's bad on NOAA. People, really? Oh, Kelly, you say it's working for you? It's up for you. So Phil's getting it. Certain people are getting it. How interesting. Huh, it loaded up. Okay, it's working for you guys. Interesting, interesting. Let's see. Let me try to load again. Nope, not for me. Someone else said it wasn't working either. So, but it looks like most people are getting it. Wonder why. Let me try a different page. Do we try to load it up again? Wonder if it's my, DNS where I'm at, if it's not coming. Yeah, I can't get it. I get everything else coming up quickly. So something, yeah, site can't be reached. Interesting. I will try it some other way here in a sec. But luckily I still have the solar wind. So what I'm going to do is I'm going to flip this over really fast so you guys can see. Oh boy, hang on. Gotta make sure I know what I'm looking at here. No, that's with the chat. Let me just do that. Okay. So yes, you can see the tabs. I know. Some people say, you're not professional. You show us the tabs. Oh, give me a break. Okay, so here's and I don't want to refresh this right now because if I do, I'll lose it. But here is the solar storm hitting now. Okay, I guess I can put this down for the moment. So this is the solar storm hitting now. Here is the solar wind speed. This is the solar wind magnetic field strength. Just so you know, the white line is the total strength of the field. The red line is the southward or northward component. We care when the field goes southward more than northward. It's not the only thing that matters for solar storms, but it's one of the major contributors to big KP levels, okay? And then, of course, the speed matters. You can see here we're sitting at, what does this say, 300? This is 300 here, 400, 500. Is that right? Yeah. So as you can see, this thing slowly ramped up, and that's how we know it's not just a stream interaction, because this thing it's I don't know. There may be people who say, no, this is a stream. I don't think so. I think this is a solar storm. And it's slowly ramping up to 500 kilometers a second. Looks like there might have been something caught in here in the middle, because now we're beginning to get some magnetic or some solar wind speed that is very smooth, low variance. So we're going to watch this as it continues to unfold. Notice the magnetic field strength has really dropped down right at the moment. I don't know if it's going to stay like that. And I want to move, I want to refresh and do something else, but I just don't want to do that if I can't get back to no. I don't want to lose this side. But the density, it was strong for a little bit. Right here, you can see this in the orange line, but not that strong. It wasn't that intense. So likely this was just a really a strong impact from the storm, plus immediately we went down to 20, 25 nanotesla. Even if it was just for an hour or so, that's enough to really bump us up to the G4. Are electric companies and utility grids worrying about this storm? Nah, the concern has passed. So it was just a very short period. Did we get an EMP from that? Yeah, likely. Was it strong enough to cause any issues? I don't know. You'll have to ask the people like Brett Carter, Dr. Brett Carter down in Australia. He might know. Low latitudes, they may have felt something. But again, not too much, because the speed ramped up slowly now that I look at it. If it had been a super big fast speed jump, then I would think so. And the density wasn't a huge density increase. So I don't think the EMP even from this was all that strong. So I think we're fine, okay? So again, the red shirt is more for forecasters, that we need to think about this in a slightly different way. And I don't know if that means that we need to think about over-predicting these structures, because that's not always the best solution, especially for the Space Weather Prediction Center. They can't have false positives. But it may mean something for the NASA M2M folks who are a little bit more, they can handle false positives. In fact, I think they'd probably rather have false positives than false negatives, because, they worry about humans. And if we had had people outside, doing an EVA at this time, that might not have been a good thing. So that's just something that we need to think about as a community. But yes, this was a surprise G4 from the perspective of it was just a filament launch, and to get a G4 from a filament launch, even though it was short-lived, is not typical of the cycles of the solar cycles we've seen recently. So we have to go back to like solar cycle 22 to see G4s from big filament launches. Maybe one, and I can think of maybe one early on in solar cycle 24, but maybe not even a G4. It may have been a G3. So this is hearkening back to a different age. And so those forecasters who kind of want to get a better handle for what that age was like, go do some forensics, dig into old solar wind data, and like from wind and from PVO, we have lots of data, solar wind data from those spacecraft, and take a look and see how big the storms were and what they look like, and then take a look at the KP indices and get yourself familiar with those, because believe it or not, and then of course the coronagraph data from that time, because these storms are different. This is a totally different sun. Okay. So let me put this stuff in, let me put the chat back up so we can chat more. And I'll keep it here. Hopefully you guys can still see yourselves and read it over the magnetic field data. Whoops. And now I covered the chat on my side. My goodness, what am I doing? Okay, so questions. Who has questions? Happy to see you. You're not wearing your brown pants. Yes, I am not wearing my brown pants. Yeah, currently looks like there's a low. I agree. There is, and we'll see whether or not if things pick up. But oftentimes when you have this side swipe, and that's how you know. And I could probably taking a risk here by popping one of the data. Okay, yeah. So when I pop in the other components, the X and Y components, it is just turbulent as all get out. There's just not a lot going on in terms of ordered field here. So this is definitely a glancing blow, which is consistent with that side swipe. So that's why I'm believing that that's what we're seeing. We're not seeing any not uncaptured stealthy CME, that stealthy solar storm that has crept by our advanced warning system. It's just that our advanced warning system is underestimating. Okay. Let's see. Wow, I'm missing that. Oh, I missed that. Something about you were. Wow, I'm so surprised. And that's all I saw. Good way. Let's see. Okay. G3s are far too old. Lol. Yeah, that's funny. I want to understand more about the ways the sun is different. Hi, Spirit. Yeah, as a matter of fact, before I do that, I want to show people that even the latest HUXT, H-U-X-T, HUXT forecast, oh good, it's perfect right with the chat. So here's whoa, stop, you're too fast. Goodness gracious. Okay, so let me back that up. So you're seeing right here, sorry about the play button, I'll play it again in a sec. This is the solar storm, the second of the two solar storms. This is that first filament eruption. So again, it's very similar to the models that you've seen. You're looking down at the sun from the North Pole. I don't have this one annotated today because I just went straight to the website. But you're looking down the sun from the North Pole with Earth being off to the right, sort of. Where's Earth? I think Earth is black. Earth, in this case, in this particular model, Earth doesn't sit fixed. Earth moves, okay, in its orbit. So you have to kind of pay attention to where Earth is as things move on. Anyway, as you can see, these two solar storms are kind of back to back. So that's why I say that over the next few days, we're going to continue to see something. And we're going to get a plus up, I believe, with this second storm. But it's not going to be, I just don't think it's going to be all that strong. Okay, but they're showing even kind of a grazing blow from that one passage. Let's see if we can play it again. Okay, so there's some of the stuff going off on the west limb, right? Because this is the east limb. Here's the west limb, and then here's that filament eruption, the big one, and then here's the second poof that's going to be hitting us. And they had it again. Once again, if you look at the dates, late on the 18th or late on the 28th, I believe, early into the 29th. Let me see if I can find where they had it. Yeah, see, here's it's about to hit. I'm not going to bother to get any closer. It's about to hit, and they're showing it on 2238 on the 28th. So, you know, solar storm forecasts, because we only have 1 or 2 views of the sun with coronagraphs, it's really, really tough to know exactly how fast these things are moving, in what direction. We can only estimate. And so there's lots of projection effects that cause us problems, especially when they're on the limb like that, you know, off to the side like that. It's hard to know if they're moving to the west and expanding out, or if they're moving more earthward and expanding out. So it's, you know, there are errors in the speed. So this is another reason why Vigil will be a really great monitor, because Vigil will be, if this is where Earth is, Vigil will be out here, and it'll be staring at the sun from the side. And so we'll see a lot better view of and speed captures of these structures, because we'll have multiple vantage points. It'll also help when stereo A, which I think this is this right here, this is stereo A, when it gets further away from Earth. That'll be a really nice thing too, because that'll help us. Okay, let's see. Leslie, just go back to, even though you just jumped on, go back to the beginning. I think you can scroll back even though it's live and catch up. So, because I'm not going to, sadly, I'm not going to redo everything, because it took me like half an hour to get here. Okay, so one person said, why is the sun different? Why are we seeing a different sun? We're coming out of something called a grand solar minimum, okay? And I'm sure there's going to be a lot of grand solar minimum folks who are very upset with me, because they really expected that the grand solar minimum was going to continue to go down and down and down to the point where our sun was not going to lose, or not going to have any sunspots visible on its face anymore. That's not what's happening. We've had many grand solar minimums over the course of time, and they vary in depth, okay? Some of them are extremely deep, and some of them aren't deep at all. And in this case, we had one that we're coming out of now that wasn't so deep as, let's say, the Maunder minimum, so that the magnetic field of the sun got so weak that sunspots could no longer rise. They weren't buoyant enough to rise to the surface of the sun and become sunspots. Doesn't mean the solar cycle died. The solar dynamo continued doing what it was doing, but it was just incognito. It was underneath the surface, so we had no visible indication of it. That's how weak back then in the 1700s. That's how weak the sun's magnetic field got. Okay, now so if you fast forward that to now, since solar cycle 22, essentially, we've been kind of on a downward trend. In the solar cycle 22, somebody remind me, was that 1990 was the peak around that time? And then we continued to go down into solar cycle 23, and then now solar cycle 24, which is the one we just got finished with. We've had a solar maximum in 2014 and 2015, and now we're in essentially the solar maximum phase of solar cycle 25. Well, it looks like we're rising again. So solar cycle 24 was when our sun had the weakest magnetic field strength in itself, because the magnetic field strength and its brightness, the strength of its storms, the amount of activity, all of that changes and you know, lessens when we go through these grand solar minimums. And I'm not going to go through the details. If you want to know the details as to why that happens, take a look at my, oh goodness, what series is it? I think it's Sunspots and Telescopes. I believe I go through that a bit in that mini course. I'm trying to remember, but I have one of my mini courses goes through it, and talking about how the sun's different hemispheres kind of affect how active it is, because sometimes it's the solar hemispheres, the north hemisphere and the southern hemisphere interact well, and sometimes they don't. When they're in agreement, then you get really big strong cycles, and when they're not in agreement, then they fight each other, and then the cycles get weaker, more complicated, but just weaker, and in general. And I'm trying to be careful, because don't talk about Carrington class events. The reason why is because it's counterintuitive. You get a bigger chance for Carrington class events during weaker solar cycles, because the magnetic field is more complex, even though it's weaker overall. But as we move out of that now, and we begin to rise to have stronger magnetic field strength in the sun, you know, overall, the two hemispheres are acting more in concert. We're getting more activity overall. That means also not just stronger magnetic field, it also means faster solar wind. When we get wind, it means bigger eruptions when we get them. So everything overall just kind of ramps up a bit. And that's what we're seeing, is these solar storms that we've been so used to over the past couple cycles being pretty weak. Well, now I think we need to err on the side of them being a bit stronger than expected, because we are getting stronger. You know, the sun's magnetic field is getting stronger. The sun's solar wind is getting faster. And we're just seeing that all over again. So that's what I'm talking about, why I'm saying this is a fundamentally different sun, is that because this happens over timescales of 11 years, it's very easy to forget. If it's been 4 solar cycles or 3 solar cycles since the last time you saw the sun do something dramatic, it gets very easy to forget, because that's 40 plus years, right? Or 35 to 40 years. And so that's an entire career for a scientist. So there probably aren't that many solar space weather forecasters who remember those days because they were forecasting during those days, right? I remember those days because I was a grad student during those days. I wasn't even, out in the professional world yet, but I was studying it, and I studied those cycles. So I have a nice knowledge of that. But we need to make sure that our operational crew and even our space weather enthusiasts understand that our sun is getting stronger again. And so we can also assuage all the fear that people have about our own Earth's magnetic field, our dipole field component flipping, because everybody's going to blame this on Earth, and it's not Earth's fault. It's just the sun is be rising again, and possibly could rise to a grand solar maximum. And that means we only have maybe 1 or 2 cycles before we could see solar cycle 19 levels again. Amateur radio operators remember a solar flux of 300? Right, we're sitting at 182 right now, I think. Imagine a solar flux level of 300 plus, okay? Those are the big cycles. Could we see those again? Yes, okay? This cycle, no. Next cycle, possibly, right? So we need to really start thinking about our sun from a different perspective, and that's what the red shirt's for, okay? So hopefully that answers that question in a long-winded fashion. Okay. Skywatch Time says, just think we didn't even have Facebook during the peak of that last cycle. You know, that's the thing, is you have to think on a much longer time scale, not human time scales, but the solar time scales are so much slower. So that's where the things become problematic, is we lose our corporate memory of what the more active cycles are like, and we become very complacent and cavalier about these things that we really shouldn't. Yeah, Spirit, you say it's all a bit more intense now. Makes sense. Great explanation. That the info in the hemispheres helps my understanding. Yes, I teach this in the SWEN program, and Dr. Scott McIntosh, as well as Bob Lehman and the UCAR NCAR crew, those guys are really leading the charge on what we call hemispheric asymmetry. And they predicted this cycle was going to be popping out of the grand solar minimum, and they were right. They thought it was going to pop out a bit faster than it has, and I'm glad that they were wrong in that capacity, thank goodness, because we wouldn't be able to handle a cycle 19 right now. There'd be too many radio bursts, there'd be too many big solar storms. Farmers, we just saw with the Gannon storm, back in May, what it did to agriculture, right? What it did to crops, the people planting corn. And it's been a very wet season as well, so these poor guys have been dealing with tons and tons of rain where they can't plant, and then they finally get a space where the weather looks great, and then we get this massive G5 that takes out all their GPS and GNSS, and they can't plant again. So they're having issues. I've talked to some folks who are planting soybeans who are in a pretty similar boat. And this is something that we had no idea was going to be as big an impact as it has been. And that's still unfolding. Oh, good, Jerry. I'm good to see you. I remember cycle 19. I doubt very few on here were around yet. Exactly, right? People weren't really born then, or if they were born, they were young. They were babies, and so they don't remember how big those cycles were and just how incredibly different our sun was. And it's not from a perspective of, oh, I feel the sun on my skin, it was so much hotter then. That isn't it. Our atmosphere protects us there. It's from a magnetic field and a space weather perspective, right? From these storms that hit us and the radio bursts and things like that hit us now. And yes, there's a good chance that we're going back to that. So we need to be aware of that. And yeah, I see Scott is awesome. Yes, he is. He's a cool dude. Anyway, so I'll get off my soapbox there. But again, that's why the red shirt is here. It's not for anybody to worry about it. What year was cycle 19? What was the solar max of cycle 19? Was that 70 or 80? 1980 maybe? Was it around the 70s or the 80s? I can't remember. I'd have to go back and take a look at it. I mean, I could look. Let me just do that for you guys. Solar cycle 19. As you can tell, I don't have this stuff in my head. You know, there's every time I have something new in my head, it takes something else out. What is going on? Oh, maybe I'm the one who's stuck. Let me try again. But see, I got that. Solar cycle 19. If you just oh yeah, looks like I'm the one who's stuck. Maybe Swipsy's just fine. I'm not sure why I'm having trouble. Huh? Yeah, Google's taking too long to respond. I don't know what's going on with my wireless. Huh. I think my T-Mobile wireless is dying. All right, anyway, that's someone else can probably put that in the chat for you guys, because I can't. Okay, 1960s. Was it that early, cycle 19? I thought it was the 1970s, perhaps. Okay. How much are your classes? Well, I do the live YouTube classes. You can see them. I have a ton of mini courses that are completely free. They're completely available for you right there. If you go to my website, you can actually see a way to navigate them. I actually have like a course curriculum, and I walk you through which courses to take, because I have the C series and the M series and the P series, and there's all these different series, and you take them in a particular order there because there are prerequisites. And so you can do that, and they're very casual, long courses, but they can get you started. If you want to go to Millersville University and take the formal courses, I teach you lots of other stuff, and it's much more rigorous in a fun way. And those courses, depending upon who you are, if you want to take it for personal enrichment and not a grade, you can actually audit the class for a lot less, like a couple $100, to be honest. So. I encourage you, if you are interested in that kind of thing, to come check it out and chat with me about it. So, okay, guys, let's see. I want to make sure, let me check Patreon to make sure that I have questions in Patreon taken care of. Also, for those of you in my Patreon family, those who can get access to the chat rooms, I will be in my office hours and on Whereby. I'll just open up the office hours for everybody today. For those who know where my VIP room is, you can talk with me there, because as soon as I'm done here, I will jump into that, okay? But let me check on Patreon to see if there's any questions from anyone who is not in the YouTube chat. Let's see. I have 5, okay. Drift says, always great aurora to be seen in northern Michigan, and of course it will be cloudy tonight, maybe next time. Yeah, Drift, likely the aurora is already past. I will take a look at the the solar wind one more time here, but I think it's probably, it may, the best of it may have already come and gone. YouTube comments, okay. Michael, that's funny. Thank you for your dedication, information, and the great job you always do. Thank you, I appreciate that, Alex. So that's it from Patreon, and let me just really quick, I know I'm off screen here, but let me see if I can get, okay, good, I get NOAA right now. I can get NOAA on my other screen. So yeah, we're sitting at a 5.3 right now for KP. I'll pull up HP here in a second. And yeah, see, they're still calling for a G3. I don't know. I wouldn't do a G3 at this point. If I go back to and I'll take off the chat real fast so you guys we can talk about this one more time. Luckily, my it looks like this data is still updating, despite the fact that I can't get to the main page. It's still updating. So you can see we're in something right here. We're getting, because of the low variance of this this speed, see, and the density's really softened. We might be in the wake now. So we're in, like, you know, when a whale, if you ever watch Whale Watcher, you know, if you ever do whale watching and the whale comes up and then it dives, and the footprint it leaves on the surface of the water is like super like glass. I'm wondering if we're seeing a little bit of that right now. But we'll see. Right now the magnetic field is still staying very, very low. I just don't expect it to be all that much. Let me look at AE index right now. I should be able to get that. What is going on? Let me do this. Let me do a different. I've got two wirelesses, so let me see if I can connect. All right, let's see if we can do this now. There we go. Real time. Oh yeah, we've had some good time today. So this is at high latitude. You guys have definitely been getting substorms. Anything above 500 for this top line. This is my quick and dirty rule of thumb. Anything above 500 on this top line is going to be substorm worthy. We've actually been having a geomagnetic storm, and our Earth is definitely storming. It's dropped down quite considerably to just below substorm level, but we are still popping substorms here and there, and that's probably because of the field is wiggling back and forth. So again, it's that we're at that point now where we're just brightening and then backing off, brightening and then backing off, but only at high latitudes. People at mid latitudes, I doubt you're going to see anything from this. You may have to wait until the 30th. Okay, when we get that second storm. The neat thing is that our field, and I probably can do this now. Let me dare do something. Let me show you. I think it was here, right before this big pop. Okay, now I know this looks messy, so let me take this stuff off. This is the last couple days. Okay, notice just the last couple days. This isn't even today. This is before the big storm hit. Okay, starting, what was this? This is the 27th, okay? 27th through early on the 28th. We've been in a solar storm, okay? This is solar storm magnetic field, okay? It's not been moving very fast, which is why I haven't talked about it. It's been very mild, but it's been causing some stuff for high latitudes. We've had some southward magnetic field up to about 10 nanotesla, okay? So it's not small. This is a decent structure. Likely it was one of these filaments that came off that we just, was a wispy thing or we didn't really see it. So it's been giving us some low-level storming over the past 24, 48 hours, which is if you go to, and I might be able to load it up now. Let me go to Swipsy. Yeah, I can load it up now. Which if you take a look at the, and I'll just keep it, well, no, you know what, I'll do this. Go to daily plots here. Actually I can probably go to 10-day. Let me do 10-day plots because that'll be better than daily, yeah. So if you look at this is KP over the from GFZ. And so here's the big storm, right, hitting over the last, 15 hours or so since the beginning of the 28th. But look at all this stuff. Okay, we were quiet. Right, and well, actually, this was actually part of the storm too. The set of storms that we've been getting little pop-ups here and there, just little things. And over the last, especially the last 24 to 48 hours, I've been going, do I need to put out an indicator because these are definitely little mini storms that are hitting us. But the speed was just so low. This is the only reason why we didn't pop up to storm level. We had the magnetic field strength. So again, even these little mini storms are strong enough. They're just, in this case, not moving very quickly. They're just lifting off gently. So this is just telling us that, we're getting these much stronger fields than we used to see. And so that also, when you have the preconditioning of getting these stronger fields, Earth is already a little bit rattled. Okay, so when this storm actually did hit, it popped us to a G4 like that. And it was like, well, if everything had been quiet prior to that, would we have popped to a G4? Maybe not. So, some of that has to do with the fact that we've been preconditioned. And that also gives me pause when I think back to the 5 days and when we have this next storm coming. What's that going to bring us? Is that going to bring us a bigger storm, a bigger impact, and a bigger response from Earth than we would get if everything were quiet prior to? And I think so. And so that's why when I did my 5-day outlooks, why I said what I said. Where, let me go back to, and I'll go back to high latitudes. Let me switch this so you can see what I mean. Right here. So when I talk about my 5-day outlooks, especially for high latitudes, I'm still expecting minor storm conditions with even maybe a 20% chance of a major storm because of the fact that we're already preconditioned, we're already ready to storm, so we could be seeing more storming than we would normally get, even from a very weak thing, especially at high latitudes. So those of you at high latitudes, keep your eye on the AE index because that's going to be your tell, okay, for Aurora or for auroral propagation or whatever else you strikes your fancy. So any other questions, guys? Yay, yeah, woohoo, she got it back. I know. I had to switch my Wi-Fi, but I got it back. So, okay. Philip says, this is the first time in more than a year I've had a whole day for playing radio without interruption. And Mother Nature had other plans. Well, switch to lower frequencies over the next day or so. That should help you ride out the solar storms, because solar storms have a tendency to cause lower frequencies to do better, right? And obviously nighttime propagation, you can have fun with 6 meters and 10 meters. It'll be unruly, it might be a bit kind of crazy, but you might get some very surprising DX. So there are some fun things about storms like this. James is saying, does it mean higher temperature? No, it's not going to mean higher temperature. It's not going to affect the terrestrial weather, not in that sense. So it's just Aurora, Okay. And let's see. Yeah, how is it going to, let's see, one of mine says, Earth's being rattled like she is. How is that going to take a big X? Well, remember, X-class, anything that's X-class or M-class, those are flares. Those are totally different. They're not, solar flares and solar storms are totally different things, and Earth looks at them and interacts with them differently. Solar storms, the Earth interacts with them mainly through the magnetic shield of Earth. Solar flares, it's mainly through the upper atmosphere, and it's also radio bursts when the sun is screaming. So that only affects even the day side, whereas solar storms, it affects mainly the night side. So it's not even the same side of Earth that gets affected. So don't worry so much about that. And if we get a big, right now we're not going to get a big X-class flare. There's nothing indicating that we're anywhere close to none of the active regions on the sun have any indication that they're going to give X-class flares right now. So I wouldn't worry about it. Like I said, the Gannon region is pretty much kaput at this point. It's just broken up into lots of little small regions that are probably going to continue to recede and disappear. So unless we see another big emerging active region, and we haven't seen any, even the little ones I showed you on the sun's far side are not that large, unless we see something change here over the next week, the chances for X-class flares will stay very, very low, and therefore also chances for very energetic solar storms will stay really low. So you don't have to worry about it. Okay. Good, so thank you. Let's see, it's that preconditioning as this Gannon region comes around the east limb that puts me on alert, so to speak. Yeah, I hear you, but again, Gannon region that's kind of gone. So I don't think we're going to be seeing anything right now. And there's not been a lot of activation near center disk right now. We haven't seen a lot of evidence of maybe Rossby waves that cause these active regions to really flare up all of a sudden as they pass certain longitudes. We're not seeing any of that right now on the, in the Earth strike zone. So again, I think it's going to be reasonably quiet unless we have some more of these filament eruptions, right? And those are the things that I think us forecasters need to really pay attention to and recognize that they're stronger. The magnetic field strengths are stronger than we are used to them being. And maybe we need to pay more attention to that, or give ourselves a little bit more space when we do our projected extremes, right? Saying, okay, well, we're going to say that, in case it's small, we're going to have what we expect, but then what our chances of it could be, we may need to kind of harken back to the earlier cycles and give us a bit more of a spread, because the cycle's changing, and we have to change with it. So, okay, guys, looks like I've answered most of the questions. Everybody's just kind of chatting. I love the fact that you guys are chatting amongst yourselves and answering each other's questions. I think that's fantastic. Okay, guys, I am going to say goodbye. Hopefully this was a good briefing for you. And again, for those in the know, come see me in my office hours. I will be getting on here shortly, okay? All right, till then. And thanks, Mike and Jerry, for jumping in so quickly.